All right. So how do we get a random sample? This is review. We talked about this at the beginning of the year. One way is to stick all of your names in a hat. So you all come in, you've done that at parties before where you put your name in and you get a door prize. That's fun, right? So that's a great way to get a random sample because it's not biased. You all dropped your name in, I shake it up and I pull out a name or a number. I give you a number. We remember that. Random table of digits, we'll work with that in a minute. Y'all remember what that's like? You have one of these in your notebook and it's on our first module there with important information. Here you randomly pick one of these numbers. Let's say I get 185. So then I start right here and I use these to gather my random numbers. We'll practice it in a second. This is one I like to use in the class with you so that we all get the same answer. If I let you use a hat or if I let you use a computer, we're all going to get different numbers and I have no way to check if you really got it. So this is kind of what I have to use for a test or something, right? That's the random table. And lastly, we can use a random number generator, a computer or a calculator. I think we can go into Google and say, I want a random number generator and it will do one for us. We're going to use our calculator. So let's make sure y'all remember how to do that. So to do that, you're going to go second plus 712 and clean your calculator. Second plus 712. And it should say RAM cleared. Now it's all clean. Whoops. So first you got to seed your calculator. So this is how you do that. Keep this and you'll have it. So just type, I just take my finger and kind of bang on the keyboard for a second. It's a, oh wait, I put a plus sign in, can't do that. Okay, so there's some numbers. And then once you get some numbers in, you hit store, go over to, whoops. What did I do now? Okay, now we're going to go to store, right? Math, probability, and number 1. Now what it should do is repeat the number that you saw right there. Once you see that number, you know your calculator is seated, which means that it's set up to do random number generators for you. So let's say that we have 30 kids in the class and I want to pick 5 of you that are going to leave right now and go to Starbucks. So I just go here and I hit math and I go back to probability, but this time you'll see random integers, number 5. And the lowest would be student 1. My upper would be student 30. And I'm going to let 5 of you go to Starbucks. And it's our dream, right? And then you just hit enter. Now, if you have an older calculator, you just use parentheses like that and you type in number 1 to number however many kids, and then the 5 right there represent how many do you want it to pull. Then you hit enter. If any of them are repeated, you hit enter again. So let's say student 28 is going to go, student 17, student 6, student 1, and student 30. Now, do you think if you were doing a random sample out of your head and I gave you a list of kids that you would pick the first kid and the last kid? Probably not. So random is it, and you can get repeats. Let's pretend like one of those is a repeat. Then you would just hit enter again and it would give you new ones. Now look at this, I got 30 again. But if I needed one more, I would just take the first one. Okay, so you could keep doing it and you could say, well, I'm going to do it this time and I'm getting student 4, 12, 19. Oh, look, I got 12 twice. If that was the case, I would hit enter again and I would only take one of those 12s. Oh, and then 4 repeats. So then 25 would be the next one, right? Y'all remember how to do that, right? So we'll practice it. We're going to warm up a little bit. I called this a warm up because we talked about it early on in the year. Let's look at some things about random samples. In order to gauge the opinions of Ohio State undergraduate students about a proposal to raise tuition by 9%, the Lantern student newspaper ran an online poll requesting people viewing their website to respond to the question, should Taft let OSU raise tuition by 9%? Altogether, 313 people responded, with 218 or 70% saying no. Give one reason why the results are likely biased. In which direction do you think the bias is likely to go? Why do you think, what makes you think this is biased? Yeah, the students are broke. What student wants to vote for more tuition, right? Would any of you vote yes? Right? Maybe we need to ask some other people. Also, requesting people to view the website, this is voluntary. What's true about a voluntary response? How many of you have ever had your oil changed or you've gone to buy something and then you get a survey on your phone? Do you answer the survey? What kind of people would answer the survey? Like people who are mad about their service? If you get bad service, are you going to answer? Yeah, you are, because you're like, but if you get really good service, you kind of just ignore it, right? So a voluntary response, it takes time to respond. So this is going to be people with strong feelings. Definitely angry people, right? So do you think more people who say no are going to respond or more people who say yes? People who say no are going to respond like, no. But if you're a yes and you kind of just want to go along with it, sometimes you don't bother, right? This is also what? Online poll. So I've just marked off anyone who's not online. They don't have a chance if they don't see it, right? Does everyone see it? In order to have a good sample, it has to be random and everybody has to have exposure to it or the chance, right? Probably this number is going to be smaller if you interviewed everyone or if you polled everybody, because the people that don't want it and that are fighting against it are more apt to answer. They don't want higher tuition. Does that make sense? So you must be very cautious, and that's what we're trying to learn this unit, is how to take samples. You've got to make sure that you're random and not getting a certain opinion of just some people. Does that make sense? So let's practice getting a random sample from this group here. A student at a large university wants to study the responses that students receive when calling an academic department for information. We want to know, are the departments answering, right? She wants to select a simple random sample of 6 departments from the following list of her study. Tell the student how to go about getting her sample. Okay, what's the first thing we have to do? How do we choose 6? We could, but let's use the number table. I gave you a sample of the number table right here, random numbers. How do we do that? What do we have to do to these things first? We have to number. Do you want to go down or across? You want to go across? So you're going in alphabetical order, which I don't like the way they did this list, but that's okay. Last block we went down, so they'll have different answers than us. We'll have the same numbers, but we're going to have different departments. So we have 27 departments and we want 6. So remember how to use a table. I'm not writing down the instructions, that you can write that down. First, number the list, right? Then we go to the first line, which I typed it here for you. And what do we circle and what do we mark off? We circle any digits that are between 1 and 27. We go by groups of 2 because it takes 2 digits, right? We have to look at the same number of digits. So we circle them if they're within that. If they're outside of that, we mark them off. So does 27 work? Yes. 81? No. 67? No, too big. 84? What about 16? 18? 32? No. 29? No, too big. 21? What? It is. That's 32. Oh, 92. 13. 37. 35. 21. 33. 77. 41. 04. Is that 6? Okay, there we go. We found our people, right? Does that make sense how to do that? That's not bad, right? So I'm going to go up here and look. I'm going to call veterinary. Where's 16? Industrial engineering, not industrial English. Oh, y'all picked math. We didn't pick math last time because our numbers were in a different order. Foreign language, philosophy, biochemistry. So we have our sample, right? Do y'all remember doing that? Are you okay picking out a sample? You don't have any bias in here. If you were going to pick them, you might be inclined to pick the ones you're interested in. Like for sure, I would have picked math, chemistry. I would think I was being random, but I would not be being random, right? So does that come back to you how you can get a random sample? And that's what this unit is all about, is getting a random sample, avoiding bias. Okay, so let's look at samples, right? What are samples? Samples are selected in order to draw conclusions about a population, right? So they're selected in order to draw conclusions about a population, right? We can't get the whole population. Now, if I had a small population like students in my second block, then I could, but more than likely we want to know about a bigger group of people than just 20, right? We want to know about students in Texas or students in the United States, okay? We have good and bad samples. The bad ones are ugly, right? The good, the bad, and ugly. A good sample is not what? What's our big word? Starts with a B. Biased. A good sample is not biased. A bad sample, on the other hand, bad samples are biased, right? Biased is our big word. We don't want to be biased. How do we keep a sample from being biased? A simple random sample. We'll talk about a few other samples when we do our jelly blubbers. But really an SRS, a simple random sample. And what that means is all members in the group or in the population have an equal chance of being selected. right? And one way is the hat method. If I wanted to offer door prizes today, then I'd have you all put your name in the hat and I'd shake it up. Of course, I would have to write the names of the people at home in the hat. So probably be better if I did slips of paper 1 to 30 and I just shake them up and oh, student 12 gets to go today. Right? We have the number table, the random number table. It's not biased. It doesn't pick all the girls or the boys or the people with Nikes or whatever. It's totally random. Or the number generator that will generate some numbers for us. More commonly called a calculator or a computer. Are you biased? Yes. You have things you like, you have things you don't like. You might have a favorite number and you always pick that. It's very hard for you to be objective, right? Bad samples would be samples that are biased. Some examples of those are voluntary response. Right? First of all, you don't have to respond. I'm giving you the opportunity and you may or may not respond. You don't have to. Now, does everyone have an equal chance? What if I stood outside the door at lunch? Actually, let's go later. 3:21, I stand outside the front office to ask kids a question. Is that biased? Very biased. Who's excluded? Yeah, every kid that has an off block. So basically all of my seniors are excluded. All of the students who are at the Dragon Virtual Academy, they don't get a say, right? Anyone who's on a field trip that day, anyone who's out sick. So that's not good, right? So voluntary response. Write in or call in polls. What do you get when someone calls your phone wants to ask questions? You hang up? I hang up. And then anyone without a phone isn't part of that. Convenience. Convenience samples. Let's say I want to know about kids in the US. Well, if I ask you guys, am I getting a good sample? No, you're honor students. Your answers are going to be different than the general population, your high achievers. I won't know what all kids do, right? So these are just some example. All of these are biased. I'm writing biased in red like it's bad. All those are biased. How do you know if you can trust a sample? Is it an SRS, right? Did everyone have an equal chance of being picked? Right? If I go to a luncheon and they give away door prizes, they pick names out of a hat, everyone who goes. Did every teacher in the school have an equal chance? No, that's a biased sample. It's only for those who attended. And that might be okay, right? For that. Okay, so why all these samples? Well, we have all these samples because we can't get the whole population, right? So we have 2 new vocabulary words that we need to go over. All right? We have a parameter and we have a statistic, okay? A statistic is a number that describes, this is what you're used to hearing, a number that describes a sample. Why did I get a G instead of a P? We know this value we get it from our sample. It changes from sample to sample. We use it to estimate population, right? So I could look at the kids that are in the classroom right now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 kids that are sitting in my room, and I could say, how many of you watch The Office? Raise your hand if you watch The Office reruns. Come on, raise your hand. Let me count. 1, wait, raise your hand so I can see how many people watch The Office. 1, 2, 3, 4, 5, 6. So 6, so that's 50%. Now I could look at my kids at home, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, wait. Can I do a poll? Oh, I can't poll you because I'm logged in. Wait, can I do it here? Okay. So how many are at home? 15 are home. I feel like I'm missing one. How many of y'all at home watch The Office? Bennett does. That's 1. Brandon. Okay, everyone put a thumbs up if you watch The Office. Put your little icon thing. Put your little reaction. 1. Come on, hurry fast. Put your little thumbs up icon. Go ahead. I watched it this break. 3. Keep going. How many of you watch The Office? Only 3 of you? I don't think they're there. Ryan, are you there? Well, 3 out of 15, which is, what is that? 1/5, 20% at home watch The Office. So statistics, this was home. No, this was here. This was home, right? So your statistics are going to change. But if I ask groups of kids, if I went to every classroom on this floor and asked how many, then I would try to figure out what percent of the population. If I were looking at this, I might say, okay, I think 35% of kids watch The Office, right? Because I have my 2 samples. So the parameter is a number that describes the population. It is a fixed number. We don't know its value. Okay, in practice, we don't know the parameter. We take samples to estimate the parameter. Like if I say 35% of all teenage kids between grades 9 and 12, or maybe I said 30% of all seniors in high school watch The Office. That would be a parameter because I said all. But 50% of second block here watches it and only 20% of those at home. That's not actually true because the people at home aren't really there. They've signed on and put, some of them have signed on and put their number there, but they're not really there. They're just a letter, like a Scrabble. Ooh, what can I spell? Okay, so that makes sense. These are two big new words, statistic and parameter. Statistics describes an entire or a sample, right? And parameter is the population. You can look at it because the letters match up, right? Parameter is for population. They both start with P. And statistic is for the sample. They both start with S, so you can remember that. Does that make sense? Your goal today is to be able to identify a sample or a population. That's all we're doing. So let's look. If you're here, you can write on this paper. If you're at home, then you're going to have to write in class kick or on a piece of paper and then submit it. So I'm going to do my parameter in orange, and I'm going to do my statistic in green. Okay, parameters are numbers that summarize data for an entire population. Statistics are numbers that summarize data from a sample, some subset of the entire population. For each study, identify both the parameter and the statistic. So you're trying to identify who we take information from and who are we talking about. So I'm going to do the statistic first. I'm going to highlight that in green. So what is the statistic? Let's read that. A researcher wants to estimate the average height of women aged 20 years or older. From a simple random sample of 45 women, the researcher obtains the sample mean height of 63.9 inches. So my statistic is going to be the sample of 45 women, right? That's my statistic. That's who I talk to. What is my parameter? Who am I looking to describe? Right? So we have not practiced a lot of writing sentences, so we're going to do this first one together. For the first 5, I'm going to have you write the sentences because we need to know how to do that. Then when you do 6 through 9, you can just highlight. We'll just do the sentences on this page. So what does a sentence look like? You need to have the script of how we write that. So we would say the statistic. I'll do one with you and then you can do them. The statistic is the average height. Why did I write height with a W? Of 63.9 inches from the sample of 45 women. Now you could rearrange those words. You could write the statistic is from a sample of 45 women. The average height is 63.9. You just need to include all those parts. And then we need to describe what the parameter is. And sometimes that's a little bit harder. You have to pull it out from what they measured. Okay, the parameter is the average height, right, of all women aged 20 years or older. Okay, and we do need to write complete sentences. We've had a lot of computer work this year, just the nature of this year, and we haven't written as many sentences as we need to. So on the first 5, you're going to write your formal sentence. On the back, you can just highlight like I did here. Now, I highly recommend going through and highlighting which one is which first so you can tell them apart. Remember, the one where you actually go in and count people or dogs or cats or whatever it is, where you sample 45 people and here's the height you found, that's a statistic because it's from a sample. You use it to try to come up with the rule for all the people. Then you say, oh, I think women age 20 years or older are 63.9 inches, right? And you may end up taking more than one sample to figure this out, but you're going to look at samples to get the parameter. Okay, so you've got 1 through 5 right in the sentences, and then 6 through 10 you can just highlight. It is in class kick.